shortest path to get food. I solved this problem in 11 minutes, and now let me try to solve it again to check how many minutes I need to solve this problem while I'm also giving an introduction of this problem and explain how to solve it. So normally for this problem we are giving a people. So these people want to eat food. The food can be any places, and we also have the obstacles. So this kind of a wall structure, it is the obstacles. So the people cannot reach to obstacles, but the people can eat food, and the people can go for direction, and we're gonna need the shortest path to get the food. So these people just need to eat one food, don't need it, but for any of the food, we just need to calculate the shortest path. So of course, this problem is gonna be a BFS. There can be two solutions. So the single source BFS is just starting from people and eat the food, and there will also be multi-source BFS. So we're gonna start from the food and then reach the people. But for simplicity, for this problem, I'm gonna use the single source BFS. Yeah, now let me just start coding. I'm gonna do some preparations. So for the RC would be length of the grid and length of the grid 0, and I'm gonna prepare a directions array. So the directions array inside it gonna be the 4 directions. Yeah, so I just need to prepare those 4 directions. So this gonna be the 4 directions. Yeah, now I'm going to check the R and C. So for R in range R and for C in range C, I'm going to check the grid. So if grid RC equal to this people, so this people is star. If it is equal to star, it means I'm going to start from the people. Now I'm gonna prepare the BFS. So I'm gonna prepare a DQ. So inside it's gonna be a tuple. So it's gonna start from the RC and with the steps of 0. And I also need to prepare a weighted set. So it's gonna be a set inside, and it's gonna be a tuple of R and C. Now I'm going to check the Q, and while check the Q, we are doing the BFS. So I'm gonna pop out. So for RC and steps should be equal to Q dot pop left. Now I'm going to check this R and C. So if grid RC equal to the food, so the food is a hash. So if it is equal to a hash, I got the result. I just needed to return the steps. So this gonna be the shortest path. So otherwise, I'm gonna check the directions. So for dr and dc in directions, I'm going to calculate row and this column. It's gonna be r plus dr and c plus dc. Now I'm going to check if it is inside the boundary or not. So for the row, it should be more than or equal to 0, less than r, and similarly for the column. Yeah, it should be less than c. And then I'm going to check this row and column tuple should not be in weighted, and r row column not in weighted set. And I also need to check it is not an obstacle, and grid RC should not equal to the obstacle. So the obstacle is x. So if it is not equal to x, we're gonna check, put it inside the weighted set. So the weighted set should append, the weighted set should add a tuple of row and column. And similarly for the Q, so Q needed to append a tuple of row and column, and here steps would plus 1. So this is my template. If we didn't find the solution, we're gonna return a minus 1. If we find it, we're gonna return the steps. So this is the entire code. Now let me run it to check. As you can see, it works. Now let me submit it. And the time complexity is R times C. As you can see, it's really fast. And R and C, it is 200 times 200. So that is why it is so fast. And this time complexity is just this R times C. It means the length and width of the grid. Yeah, as you can see, this is a typical BFS problem, and It's just like reading the problem. If you understand it, normally you can solve it, because no matter which way, it's gonna be easier than you expected. No matter the single source BFS or multi-source BFS, it's gonna be similar. You just need to find a star, find these people, and then you start the BFS until you find a solution. If you didn't find, you're gonna return a -1. Thank you for watching. See you next time.